All right, class. So today we're going to do the guided practice problems for this week. Please do only the problems that I'm telling you to do. We're going to do all of these problems on this first part of the page, and we're going to do these here, but we're going to wait to do compound interest the week that we come back. However, we're just going to submit this when we're finished with number 20, okay? So when we finish with number 20, we're just going to submit this assignment. All right, so let's go back to the front. Yesterday, I wanted you to tell me if these sequences were geometric sequences or not. And then if it is a geometric sequence, what is the common ratio? What's the number that's being multiplied to get to the very next number in that sequence, okay? So that was what your instructions were to do yesterday. All right, so let's go through this together. Geometric sequences, and I'll go back to what we wrote in our notes and everything. Geometric sequences are sequences where you multiply the same number to get the next number in that function or sequence. Okay, let a couple people in. All right, so here, is this a geometric sequence? Is there a number that's being multiplied to get to the next number in this? There is. This is a geometric sequence. So we're going to write geometric sequence. Okay, if you haven't done so, please make sure that you write or type that in. What's the common ratio? What's the number that's being multiplied to get to the next number? -6. Okay, you're multiplying -6 to get to the next number here. Yeah, -6 times this -1 is +6. Then -6 times this +6 is -36, and so on and so forth. Okay, very good. This is our answer here. All right. Number 2. Somebody different, please. Is this a geometric sequence? Is there a number that you are multiplying, same number used to multiply to get from here to here to here to here and so on and so forth? Is this a geometric sequence? No, it's not. This is not a geometric sequence. This is not a geometric sequence. Okay? So therefore, there's no common ratio. Number 3, somebody different. Is this a geometric sequence? Somebody different. Charles, is this a geometric sequence here? All right, so let's do this one then. Let's do 4. Let's do 16. Let's do 64. And let's do one more. What do you think the next number would be? Hmm? All right, so this, because this is a typo here. Okay. All right, so let's do this one. This would be a geometric sequence here. And the common ratio for this one, somebody different that hasn't said anything yet. Leland, it would be 4. Good job. Okay. All right, so let's look at number 4. Let's look at number 4. Make this correction. Raise your hand if you need more time to write this down. Okay, so let's look at number 4. Somebody different. Is this a geometric sequence? This is a geometric sequence. Very good. This is a geometric sequence. What's the common ratio here? Common ratio is 5. Okay? That's the number that's being multiplied to get to the next number. All right, so let's look at number 5. Let's look at number 5. Somebody different. Alana, is number 5 a geometric sequence? Yes, it is. This is a geometric sequence. Very good. Cody, what is the common ratio for this geometric sequence? 2. Guys, if you don't know, just say you don't know. So we don't have to wait because we're limited on time, okay? So just say that you don't know. All right. It's no harm in not knowing, but because we're in this kind of environment, it's better for you to just say that you don't know, so we can just move on. I don't know if there's a lag in the system or what, but just say you don't know. Okay, so we're not waiting. All right, so let's look at number 6. Is number 6 a geometric sequence, Michael? Okay, very good. It is a geometric sequence. What is the common ratio for that? Akeem, what do you think the common ratio is? Fun 2? -5. R is -5. Good job. Okay. All right, so now let's look at this right here. Raise your hand if you need more time for this top part. All right, I'm going to keep on moving. All right, so let's look at it. All right, so here it says, given the explicit formula, and remember, explicit formula are going to be formulas where you substitute the desired term, the term that you are looking for, to get your answer, okay? So these are going to be explicit formulas, and we are going to find the first 5 terms and then find the 8th term, okay? So when we're looking at this geometric sequence formula, let's go back and look at this. This is A sub n. N is the term that you're looking for. So if you're looking for the 10th number, then n is going to be 10 here. And you're going to put 10 here and 10 here because you got n in 2 places. A is going to be the first term in the sequence. A lot of times they put A sub 1. It's the first term in the sequence, okay? So that's your A. It's not your starting amount. It's not your 0 number. It's the first number. Not the 0 number, but the first number, okay? Your R is your common ratio. That's the number that's being multiplied to get to the next number in the list. And the reason why they put n minus 1 and not just n is because this A right here is not starting with your 0 number. It's starting with the first number, okay? So that's why they got n minus 1. All right, so when we're looking at these explicit formulas, there's no A here. There's an R, but there's no A. So you automatically assume that because there's no A here, your first number is automatically going to be 1, okay? So that's your first number. Your common ratio is this number right here that's raised to the n minus 1 power is 3. Your common ratio is 3. So you're going to multiply 3 to get to the next numbers in the list. So what's going to be the second number in this list if your common ratio is 3? If your common ratio is 3, what's going to be your second number in the list? 3. What's going to be the third number in the list? 9. Good job. What's the fourth number in the list? 27. Okay, and it asks for 5 numbers, so we need one more. 27 times 3 Common ratio is 3. What's that number going to be here? Very good. So these are your first 5 numbers, okay? Find your first 5 terms. So now we're finding the 8th term, so we're going to plug in 8 into this explicit formula. So we got a sub 8, because we're finding the 8th number, so plug in 8 for n, is equal to 3, and again, 8 is in, 8 to the 8 minus 1 power. So when I do this, use order of operations, this is going to be 7, so this is 3 to the 7th power. So here we have 3, caret key, 7. Okay, and that gives us this 2,187. So the 8th number in the list, this is 8 sub 1, the 8th number in the list is equal to 2,187. This is your 8th number in the list. Okay, any questions about that? Okay, raise your hand if you're still writing that one down. All right, I'm going to keep moving. Let's look at this one. This is an explicit formula again. So your first number in the list right here is 2. Your common ratio is 1/4. R is 1/4. And how do I know that? Again, look, by looking at the formula here. This number is your first number, not your 0 number or your starting number, but the first number. Your R is your common ratio raised to the n minus 1 power. All right, so your first number is 2, so your second number, you're going to multiply 2 times 1 over 4. What's 2 times 1/4? Remember, you do it like this. So you can say 2 times, and you can put in parentheses 1/4, and that gives you 1/2. Okay? Gives you 1/2. So, or remember how when you multiply a whole number times a fraction, you change the whole number into a fraction by putting a 1 under it and multiply straight across. So that's going to be 2 over 4. Reduce that to 1/2. Okay? So at any rate, it's going to be 1/2. We're going to keep it as a fraction because that's going to be easier to write. Okay? Now you're going to multiply each term by 1/4. So let's multiply this by 1/4. 1 over 4. You're going to get 1 times 1, which is going to give you 1. And then 2 times 4, which gives you 8. So the next number is going to be 1/8. Okay? So let's multiply again. We got the third number. We need the next number. Got to do the first 5 terms. So we multiply 1/4 times, well, the 1/4 times is 1/8. So 1 times 1 gives me 1 here. And what does that give me on the bottom? 32. Good job. Okay? Somebody different. So we're going to multiply 1/4 again. That'll give us the 5th number in the list. So 1 on the top. What does that give me on the bottom? One. Very good. 128. 128. Okay, so these are your first 1, 2, 3, 4, 5 numbers. It's first terms. First 5 terms. I'm going to erase this so I have enough space to find the 8th number in the list. So all we're doing again is taking this explicit formula and substituting 8 to find the 8th number in the list. So this is a sub 8 because you're finding the 8th term is equal to 2 times 1/4 and raise it to the n minus 1. The 8 minus 1, which is 7. So I'm going to go ahead and put 7 here. 8 minus 1 is 7. Okay. So now I'm going to type this in my calculator to see what I get. All right, so this is going to be 2. I put times 1/4. So I put in parentheses 1 divided by 4. So that's my 1/4. Caret key is right here. my exponent, and I'm raising it to the 7th power. Okay, raising it to the 7th power. And so now that gives me, look at this. This gives me this number in scientific notation. It has a negative at the end after E, so we knew this number is very small. This number, when you see that E, that number is written in scientific notation. I don't know if you guys did scientific notation last year. For those of you that are in advanced mathematics in 7th grade, scientific notation, we had so much going on last year, so it's all good. So you write 1.22. I'm just going to put 2 places behind the decimal. And to the E, you see where it says E? E is the same as saying times 10. So we're going to put times 10. And the number after E is the exponent. Okay, so this number is written in scientific notation. They use scientific notation for extremely small numbers that can't fit on the calculator, or extremely large numbers that they just can't fit in the calculator. This is an extremely small number because it's a negative exponent. So the original number here would be all these numbers. I remember I stopped to cut the numbers off, but really you move the decimal 4 more times. 1, 2, 1, 2, 3, 4. So my number would be 0, 0, 0, 1, 2, and that long number that you saw on the calculator. That would technically be my answer. It's a really, really small, very, very small number. Okay. Please make sure you copy that down. I'll pause for the calls. Please raise your hand if you're still writing. All right. Let's look at number 9. Here, this explicit formula. Remember, explicit formulas are formulas where you can substitute the term that you're looking for to get the answer. Recursive is when you have to know the previous number to get the next number, and however many terms there are, you have to do that formula that many times. So if you're trying to get to the 5th number, you got to use that same formula 5 times to get to the 5th number. That's recursive. All right, so here, your starting number, not your starting number, but your first number in the list is this right here, negative 2.5. Your common ratio is 4, so R is 4, so you're going to multiply by 4 every single time. So if this is my first number, let's multiply by 4. So we got negative 2.5 times 4. And look at what that gives me. That gives me a negative 10. That's your second number. So we're going to multiply by 4 again. And what does that give me? Very good. And then you multiply times 4 again. And what does that give me? Very good. 1, 2, 3, 4. We need one more time. Multiply by 4 one more time. And what does that give me? Very good. Okay. All right. Excellent job. These are your first 5 terms. Now you want to figure out what your 8th term is. So you use the explicit formula and substitute 8 in the place of n because you're looking for the 8th number. So this is a sub 8 is equal to a negative 2.5 times 4 to the 8th power. So it says n minus 1, so that's 8 minus 1, which is 7. Okay, so let's type this in. So this is negative 2.5. Oops, sorry y'all. Forgot my decimal. Times 4, caret key 7. Okay? And that gives you the 8th number is going to be negative 40,000 960. Any questions about that? Now see if you can do number 10 on your own. We'll pause for the calls. All right, good people. Let's see. There we go. All right, so here we're going to start. Our first number is -4. Our common ratio is this right here, 3. R is 3. So we're going to get the next 4 numbers. We want 5 numbers, the first 5 numbers. So let's multiply by 3. So what's my next number going to be? -12. Somebody different. What's the next number going to be? Braden, what's the next number going to be? Charles, Braden, somebody. Maggie, -36. Good job. Okay. What's my next number going to be? Anybody? -108. Good job. And then that fifth number, what's that going to be? Negative what? Very good. Excellent job. These are my first 5 terms, okay? So now I want to figure out my 8th term. So I'm going to substitute 8 into the explicit formula. So this is a sub 8. The 8th term is equal to -4 times 3 to the 8 minus 1 power. 8 minus 1 is 7. Okay, so this is what we're going to type in, see what we get there. All right, so we got -4, we got times 3 caret key 7. Okay, and that's going to give us a sub n is -8, negative 8,748. This is the 8th number in the list. Okay, all right, let's go to the next page. All right, here we're given a recursive formula. Recursive formula again are going to be the formulas where you have to know the previous number to get the next number. And if you're looking for the 5th number in the list, you have to do that same formula 5 times. Okay. So given the recursive formula for the geometric sequence, we're going to find the common ratio or the first 5 terms, and we're going to write the explicit formula. Okay, so watch how I do this one, because then you're going to do this the same way on your own, okay? All right, so first I'm going to identify what my R is. Look at the formula. This is A sub n is equal to some number in the list, probably the previous number in the list, times 2. Remember, it's a recursive formula, okay? So my common ratio is going to be 2 because I'm multiplying. Look at what I'm doing. I'm multiplying the number in the list times 2. So I know it's a geometric sequence, not because they just tell me, but because I'm multiplying each number by 2. So my common ratio is 2. My first number is 2. So I'm going to start with my first number is 2 and multiply by 2 to get to the next number. And they use the same number. I don't know why they did that. They should have used a different number, but whatever. So we're going to find the next number by multiplying it by 2. So we got 2 times 2, which is 4. Then 4 times the common ratio, which is 8. And 8 times this common ratio is 16. Then 16 times this common ratio is what? 32. Then 32 times the common ratio is what? Very good. Okay, so that's 1, 2, 3, 4, 5. Well, I did too many numbers, but that's okay. All right. So now we want to figure out how to write the explicit formula. Like we did on the other page, we're going to write the explicit formulas that look like this. See, we're using this right here. So we're going to say A sub n This is the explicit formula. A sub n is equal to, we got A, well, actually A sub 1 is going to be the first number, which is which is 2. So we're going to go ahead and put 2 here. Okay. The common ratio is also 2, so we're going to put times 2, and we're going to raise it to the n minus 1. Because we didn't use the 0 number, we used the first number in the list. So this is our explicit formula. And again, we got our explicit formula right here. The first number, the common ratio raised to the n minus 1 power. Okay? All right, see if you can do number 12 on your own. Do all of these things for number 12. So for this one, the common ratio here is -3. We started with -3. They made it the same number. I wish they wouldn't have done that, but it is what it is, okay? So since -3, and you multiply them by -3. So this is going to be +9, then -27, then +81, then -243, right? The explicit formula is going to be A sub n is equal to the first number, we got -3, times your common ratio, which is also -3, raised to the n minus 1 power, because you're starting with the first number and not the 0 number. Okay? This is your explicit. Quickly raise your hand if you got all of this right. Anybody? Nobody? Oh, okay. 2 people. Thank you, Jesus. Good job. Okay, very, very good. All right, so let's do 17 so you can do the others, okay? Because we're going to stop at 20 and submit this assignment. All right, so let's look at this. It says, given the first term, you see right here, you're given the first term, the first number, and the common ratio, your R, of the geometric sequence, find the recursive formula and write the first 3 terms in the sequence. Look, this is the recursive formula up here. This is one of them. You could use next now equation, but they want you to learn how to write a recursive formula looking like this. Okay, so that's what we're going to do. All right, so we got A sub n, okay, any term that you're looking for is going to equal to the A sub n minus 1, generically write that, and the number that's being multiplied is going to be the 6. Okay? And what number are they starting with? They are starting with, well, the first number is going to be -4. This is your recursive formula. If it was a next now formula, it would go like this, starting at forgot to put what it's starting at, starting with -4. Sorry, y'all. Then it's next is equal to now, and you're multiplying by 3 every time. So I'm sorry, 6. I said 3, but I meant 6. So this is how you write the recursive formula using the next now equation. This is the one they want, but you need to understand both of them, okay? The other thing they wanted you to do is the first 3 terms. So the first is -4, and you're multiplying by 6. So the next number is going to be -24. And the next number, when you multiply this times 6, is going to be -144. Okay? Any questions about how I get any of this? Okay. I'm going to do one more, and then you're going to do last 2 on your own, okay? All right, so let's look at it. You're going to write your recursive. We're going to write a recursive formula like the one that we've been doing on this on this sheet. So generically, we're going to say a sub n is equal to the a sub n minus 1. We generically write that. Now, what are you multiplying to get to the next number? Your common ratio here again is 6. And use 6 again. Okay? And then you have to tell them what the first term is. The first number, a sub 1, in this problem is 4. So this is your recursive formula. To write the recursive formula using next and now equation, you do starting at, and your starting at is 4. Then you do next equals now, and you're going to multiply your common ratio with 6. You're going to multiply 6 to get to the next number. Okay? So when I do that, this is what it looks like. 4 is the first number. When I multiply times a positive 6, I get 24. When I multiply 24 times a positive 6, I get 144. And those are the first 3 terms. Any questions about how I got these answers? All right, so now I want you to do 19 and 20 and submit this assignment. You should have all the way through 20 completed. Any questions before I stop the video? Okay, 19 and 20, complete those and let's submit this assignment. Okay, let's do those now, please. You need to go back and watch the video. Please go back and watch the video. If you have questions, please feel free to ask your questions, okay?